Okay, when multiple parts integration are required, we can do something called tabular integration. And after you see one done, it seems to get a little bit easier. Okay, so here I have x squared e to the x dx. So I need to choose a function, one of the functions to represent u, and another one of the functions to represent dv. So in the first column, I'm going to let f of x give f of x and its derivative. So what I'm going to do, let me tell you what I chose. I chose f of x to be the x squared, and I chose g of x to be e to the x. In other words, the u is going to be x squared, the dv is going to be e to the x. Well, actually it's e to the x dx, but so what I need to do here is take the f of x. So here's f of x, x squared, and then the first derivative of f of x would be 2x, and then the second derivative of f of x would be 2, and then finally the third derivative of f of x would be 0. Okay, now over here I'm going to let g of x, and that should be a lowercase g. So g of x is going to be e to the x, and then I'm going to integrate that. So if I integrate e to the x, I get e to the x. Well, then I'm going to integrate it again, and I'm going to alternate signs. So the next one's going to be minus e to the x. So I start out with plus e to the x, whatever the integral that is, and then I integrate this again, but I change signs to minus, and then I integrate this again and go plus. Now I'm stopping here because over here I have a 0 for my basically over here is your du's. So anyway, so I'm going to ignore this first one right here, this first integral, and then I'm going to just multiply this times this, and then multiply this times this, and then multiply this times this. And then here you're stopping here because if you multiplied 0 times the next one, you'd get 0 anyway. So you're going to have x squared times e to the x, that's going to be your first term, and then 2x times minus e to the x, that's going to give you minus 2x e to the x, that's your second term, and then you take 2 times e to the x, and that's going to give you the third term, 2e to the x. And then there won't be any more terms, so we'll just add the positive c here. And so this is actually similar to what I did earlier where I had to do multiple parts integration, but this sort of allows you to do that in a more structured way. So let me take a look at another one here. Okay, so I'm going to start out, I'm going to let my u be x cubed, or the f of x, x cubed, and I'm going to let my dv be the cosine x function here. So then here's my so I start out with my dv there and my u here, okay, and then for the u function I know that u is x cubed, the derivative of x cubed is 3x squared, the derivative of 3x squared is 6x, the derivative of 6x is 6, and then finally the derivative of 6 is 0. And then over here I can integrate. So if I integrate cosine x, I get sine x. If I integrate sine x, I get minus cosine x. If I integrate minus cosine x, I get minus sine x. And then if I integrate minus sine x, I get plus cosine x. Okay, but here's the tricky part. You're going to take x cubed times a positive sine x, so that'll just give you x cubed sine x. Then you're going to take 3x squared times, and remember we alternate signs, so this will be minus, but since this is also minus, so you have 3x squared times minus minus, so you get 3x squared times positive cosine x, so you're going to get 3x squared cosine x. And then you're going to take 6x and you're going to multiply it by positive times a minus, so that's going to be minus sine x. So minus 6x times sine x. And then you're going to take 6 times a minus cosine x. So that would be minus 6 cosine x. And then since you have a 0 here, that's as far as it goes, and then you can go ahead and add your plus c. Now this is actually helpful in developing a reduction formula. So let's say you wanted to find a formula for integrating the cosine of x to any power. Okay, well, the first thing you can do is, in order to get two factors, we can actually write this as cosine x and then times cosine x to the n minus 1 power, and then that way that product is the same as cosine of x to the nth power. Well, when you do that, then you can let u be cosine of x to the n minus 1 power, and then of course when you take the derivative of that, you get n minus 1 cosine of x to the n minus 2 power, and then of course you have to invoke the chain rule times the derivative of cosine x, so you get minus sine x dx. And then the dv would just be the lone cosine x here, so dv would be cosine x dx, and so v would be sine x. So using parts integration, now I can write this as, okay, so here if I do uv, I would take, let's see, uv would be, the u would be the, sorry, the dx doesn't go there. Alright, so the u would be the cosine to the n minus 1, so it would be this factor, and then the v would be sine x, so there's your uv, and then plus n minus 1. Okay, well, let me tell you what we're doing here. This integral would be the integral of v du, so it would be sine x right here times all of this. Okay, well, if you put all that together, we can pull the n minus 1 outside because that's just a constant, and then I have a minus sine x times sine x, so that's going to be minus sine squared x. But since the formula says it's going to be minus the integral, then I went ahead and factored the minus out here. When I multiplied sine x by minus sine x, I factored the minus out here, and that gave me a plus. So I ended up with a plus n minus 1 times the integral of sine squared x, and then of course times the cosine of n minus 2 dx. Okay, so basically what that gives you here, let's see, it gives me, okay, well, I'm going to replace sine squared x here with 1 minus cosine squared x, and then when you distribute this, you're going to get, let's see, you're going to get really two integrals here. So you're going to have n minus 1 times cosine n minus 2x dx, so that would be that, and then you're going to have n minus 1 times the integral of minus cosine squared x times cosine of n minus 2, and if you add exponents, that's just going to give you cosine nx. So you get minus the quantity n minus 1 times the integral cosine nx. Okay, now we're going to add n minus 1 cosine x to both sides of this equation. So if I add it here, I get n minus 1 cosine nx dx plus this, which will give me that. And of course, if I add it over here, it's just going to cancel all that. So I end up with just the cosine n minus 1x times sine x plus n minus 1 times the integral of cosine n minus 2x dx. So it's getting long, isn't it? Okay, so I have n minus 1 of these plus 1 of these. So that would give me n of these. So that gives me n of these integrals. And now I have n of these integrals equals to this expression over here. So now to solve for this integral, just divide everything by n, and you'll get that integral by itself. And here you'll have 1 over n times this first term, and then here you'll have 1 over n times this, so that would just give me n minus 1 over n, and then finally times the integral of cosine n minus 2. So finally I get a formula here. So let me just show you how that would work. Now that we have this formula, we can show you how it works. So if I have cosine fifth x, well then of course n would be 5, right? So using that formula, you'd have 1 over 5, so I'd have 1 over 5, cosine of n minus 1x, so that'd be cosine fourth x, and then times sine x. And then over here I'd plug in here and I'd get 5 minus 1 is 4, and then over 5, n is 5, so I get 4/5 times the integral of cosine, let's see, if n is 5, got a typo there, n is 5, so that's actually going to be, that should be a 3 right there. So integral cosine cubed x. And now here you actually would take this and you'd probably have to use this formula again to integrate this cosine cubed x. Okay, so it gets really nasty, but at least you can see there is a formula that you can use now to integrate powers of cosine. Okay, here's an application of this. An electronics company generates a continuous stream of income of $4 million per year, where T is the number of years that the company has been in operation. So if T is 1, it's 4 million. If T is 2, it's 8 million, and so forth. Find the present value of this stream of income over the first 9 years at a continuous interest rate of 12%. Okay, so continuous compounding, remember, is is the present value for continuous compounding. It's actually a divided by e to the RT, or a times e to the negative RT. So if I put a in, that's the future income. Okay, so that would be 4t in millions. So let's just put 4t in there. And then we get e to the negative 0.12t here because the rate is 12%, so in decimals 0.12t. And then over 9 years, so basically I want to sum that over 9 years, so I want to integrate that function from 0 to 9. Now, if you do this by using integration by parts, then you can say, okay, let's let u equal 4t, and then let's let dv equal the e to the negative 0.12t dt. Now I'll let you do the parts integration, but you can use integration by parts, and then when you do, you can evaluate that using the fundamental theorem of calculus from 0 to 9. And this is the answer that I got. So I know you might want me to show you the work, but I've already shown you how to integrate by parts. So integrate that by parts and then evaluate it from t equals 0 to t equals 9. And then it will give you that formula. So basically this is the formula I got, and then when I evaluated that from 0 to 9, I got 85.6 million. Now you can freeze the video and read that last problem, and if you want to, you can try that. And I gave you the answer and how to set it up, and I also gave you the final answer to the problem. And so I think that's enough problems of using integration by parts. And so now we'll move on to the next section. And in the next section, I'm going to show you how to integrate problems using partial fractions decomposition.